Hi, welcome ladies and gentlemen. We're going to be looking at Lesson 8.1, Relations and Functions. Make sure you're taking notes as you go, looking for the learning target, and writing down questions you need or you have to come to class and ask. Okay, the ordered pair form a relation. A relation is a pairing of numbers in one set called the domain with numbers in another set called the range. Each number in the domain is an input. Each number in the range is an output. A relation represented by ordered pairs, the inputs are the x values or x coordinates and the outputs are the y coordinates. So right here's an example of mapping, and this is the domain or the input, and it's all of those values we would have for our input or our domain. The range is what we get as an output. This is dependent on what we put on the input. So range depends on range depends on domain. So if we put 1 in, we get 60 out as our range. And these are all of our range values, 60, 100, 160, 210, and 270. If we come over here, you're welcome to read the example, but we're looking at someone driving, and so we have a table. The hours represent the domain values, or also the x, and remember that can also be the input. So we have domain, x values, and input, all referring to the same numbers. So if we're driving 1 hour, we're going to go 60 miles. So that is our range or our y values. Also remember the range and the y values are also known as the outputs. So for 1 hour of driving, we go 60 miles. So if I'm driving 2 hours, if that's my input, then I'm going to be getting 100 miles is my output. So I can see that based on what I'm driving, how many hours depends on the miles depends on the number of hours I drive. So if we come over here, as I said, this was mapping. This is listing our domains and our ranges. So the domain is 1, 2, 3, 4, 5, 6, our x values or our inputs values. And the range is the output, also known as the y values, and those are 60, 100, 160, 210, and 270. So far we have mapping, listing, and a table. We can also write them as ordered pairs, with the x values as the domain and the y values as the range. So my ordered pair 160, or another ordered pair is 2 100, and the other ordered pair is 3 160, and so on. Please pause this video to make sure that you get this copied into your notes. Pretty much everything on here is essential. You need to know what a domain is, a range, a relation, input, and an output. And let me go real quickly over what a relationship is. It's just saying when this happens, this is going to happen. If this happens, then that will happen. So kind of like an if-then statement that you'd use in science class. If this, then that. So it's saying there's some kind of relationship happening. Okay, go ahead and pause. Back to it. Go into Schoology, click the link, and you can watch that video if you find that you need a little more clarification. It is in the PowerPoint, so you would find it under the PowerPoint. Okay, multiple forms of representation. So in example 2, represent the relation. Remember that there's some kind of relation. If I do this, then that happens. That if you put 2, you get 0. Or 1, negative 1. 2, you get 2. 0, 0, negative 1, 1 as indicated. So if we were to do that as a graph, and we're going to plot those points on the coordinate graph, we would see we have a negative 1, negative 1, 1, 0, 0, 1, negative 1, 2, 0, and 2, 2. So we've graphed our points. That is one way of doing that. Another is the mapping. So we have the inputs and the outputs, and we can see when we have negative 1, we get 1. That's what we were told up here. If we put in negative 1, we get 1. So we can see that. So here are a couple more options. So we have mapping, listing, tables, and graphs. Okay. A square is a rectangle, but a rectangle is not always a square. This is the same for functions. Functions are relations, but not all relations are functions. I know you're going, what? Think about it. A square is always a rectangle, but are all rectangles square? No. That's the way a function behaves. Functions are always relationships, but relationships are not always functions. So a function is a relationship where each input gets exactly one output. in that case, the output is a function of the input. So if I have a certain number and I put it in, then I better get that same number out every time. So if I'm driving 60 miles per hour and I put 1 in, I should get 60 out every time I put 1 in. So if I put 1 in, I get 60. The next time I drive an hour and I should get 60. For the next 1 hour, I should get 60. You should see every time you're getting the same answers. If I go 1 hour and I put 20 in, I am no longer a function. I'm still a relation because the miles I travel will depend on the amount of time in the car. But it is not a function then. So every time I put the same number in, I need to get the same number out. So functions, again, you're going to notice I keep putting this up here. Function is, you get one input, there is exactly one output. So the output is the function. So here's some examples. Tell whether a relationship is a function. Explain your reasoning. So if I look at the ordered pairs, which you can see are down here in table A as well, 160, 2, 100, 3, 160, 4, 210, 5, 270. For every one number I put in, am I getting a same number out? So if I put 1 in, I'm only getting 60. I'm not seeing any other options. So at this point, this appears to be a function. Let's look at B. 2, 0, 1, 1, 2, 2, 0, 0, negative 1, 1. Now you'll notice the first one lined up really nicely. And that's because none of my numbers repeated. When I came across, I just did it in order, numerically, so that I could see if there was a pattern developing. So for my coordinate pair 1, I can put 60 in. For my coordinate pair 2, I could put 100 in. I came over to the table here, and again, I'm putting my numbers, my inputs in order, numerically, so that I can see if a pattern develops. So I see that negative 1 is my smallest number, so I put that in. And then I saw, when I was looking, I have different things that repeat. These 2's repeat. So I put 0 in, and I got 0. I put a 1, but then I saw I had a 2 and a 2. So I only wrote 2 once here because I only have, 2 is the same each time. But what I notice is when I put 2 in here, I got a 0. When I put in 2 here, I got a 2. Something's awful funny about that. That doesn't make sense. This table is actually not the best example. This should be showing a 1 here. This should be showing when I got a 0, I got a 0. And when I put a 1 in, I got a 1. And I could do 2, 0, and then 2, 2, and I could see it visually that way too. So I will fix that for the next time. So please just ignore that right there. But we can see that when I put 2 in, I get 0. I put 2 in, I get 2. That's odd. So that is not a function. I cannot put 2 in one time and get 0. Put 2 in again and get 2. Something is wrong with that. So it is not a function. Make sure that you get that down. Okay. If I come over here, I have 2, and I drop that line down, it's going to hit another 2. If it's touching in 2 points like that, I cannot say that that passes the vertical line test because my vertical line is touching it in 2 places. So that would not be a function. Let's come over here. If I drop a vertical line here, it only goes through 1 point. If I look at the y-axis, which is a vertical line, again, 1 point. If I look here, 1 point. Again, here, just 1 point. So again, I've checked, nothing is going to go through more than 1 time. So this is a function. Okay. So ladies and gentlemen, to ensure that you're watching videos, I need you to go ahead and answer this question. Looking over, it's going to have a little word problem for you. It talks about the years versus the length. So how many inches would that alligator be in 6 years? Is this a function? Why or why not? Please turn this in on a piece of paper with your name stating that this is the answer for the 8-1 video. Thank you.